Woohoo, welcome back. Today we're going to be talking about the average value of a function. Yay! And because SpongeBob was hanging out and he was having so much fun with the math, we said, why not come back? So SpongeBob is here and really impressed that you came back after doing all that work. Man, that work was hard. But now this is no longer work. Woohoo! Nothing else will be work in this class. Yay! But it will be an average. So let's go ahead and get in. So we're going to start off with a problem that I hope is really very familiar and not too taxing. Find the average of these values, 10, 8, 6, 4, and 3. And hopefully, if I say find the average, you know that what I mean is the mean, which is the average that you get when you add them all up, 10 plus 8 plus 6 plus 4 plus 3, and divide by 1, 2, 3, 4, 5. Divide by 5. So the average is the sum over the number of things. And if we add this up, 10 plus 8 is 18. 6 plus 4 is 10. So 18 plus 10 is 28 plus 3 is 31. All over 5. Okay, I'm going to go out on a limb and say this is 6.2 or 6 1/5. Your choice. Okay, woohoo. I hope you already knew that. If you did not, basically the average, the mean, is the sum of the values all over the number of values. And ever since Calculus 1, let's be honest, we've been kind of, mad with power. And anytime we start adding stuff together, we're like, why add? Why not integrate? So what we're going to do is we're going to expand this concept to the average value of a function. Now, how is this different? Well, when I find the mean of a bunch of values, this is a discrete set of numbers. So in other words, I've got 5 numbers. I know exactly what they are. There aren't an infinite number of values. When we come here and we talk about a function, what's the average of the function? How many different y values are there between x equals 2 and x equals 6? And I'll say, 3x squared, y equals 3x squared. That's a what? You guys know. Yeah, it's a parabola. It's kind of a skinny parabola. Looks something like that. And between x equals 2 and x equals 6, so there's 2. There's 6. I'm going to say my magic words, not to scale. And I'm going to say between this point and this point, what's the average value? And that's a weird question, right? Because how many points are there between these 2 points? There are an infinite number of points. So can you do this? If you add them all together, you're going to get infinity, and then you're going to divide by infinity. What does that even mean? So that's weird. But if instead I said, instead of thinking of adding them all and dividing by all of them, is there a middle point? And if I said that instead, we could talk about what the middle of this looks like, right? So when you think about the average of a function, don't think about adding together an infinite number of points. Think about what is the middle, because that's what an average is looking for. Okay. I love to write out my thoughts. Obviously, we can't use the same approach that we used in the previous example, because here there are an infinite number of values. However, we can use the fact that definite integrals are just another way of taking a sum. And in fact, they are a way of taking an infinite sum, right? We added up all of them. So we come up with the average value of a function over an interval, and it's f AVE. Now, this is supposed to be average, but I know it looks like fave, and I love that. I love that for everyone. Now, we get the sum. Here's the sum from A to B. And notice that instead of saying how many values there are, we just take the distance traveled. We take the difference between B and A, which is an interesting choice, but it does give us some really good results. Okay, so shall we give it a try? So F sub AVE, or F sub average, is equal to, between 2 and 6, it's 1 over 6 minus 2 of the integral from 2 to 6 of 3x squared dx. Okay, not too bad. This is going to be 1 over 4. And the definite integral of 3x squared dx, well, that's just x cubed, right? Between 2 and 6. What do you guys think? Right, because we raise x up to 3, and then we divide by 3. That cancels the 3. So we get 1/4 times 6 cubed minus 2 cubed. Not everyone knows. I happen to have it memorized. That 6 cubed is 216. Yeah, you got it. Minus 8. So that's going to be 1/4 of 208, which is going to be 52. Yay! Now, the problem is that it's really hard to know what we actually have. So on the next couple pages, after we talk about some mathy stuff, I've got some graphs so I can actually show you what this represents. Because just looking at the numbers, it's like, okay, I did it. It's 52. Yay. So on the next page, we're actually going to talk about what in the heck that means. Okay, you guys ready? Dun, dun, dun. But first, we have the mean value. Now, I always thought this was like the angry value. You know, it's like the mean value. It's really mean to it. No, so this is the average value theorem for integrals. There are other mean value theorems. So this one is the one for integrals. If f is continuous, so in other words, you can take integrals on an interval, it's a closed interval, then there exists a number c. There's some c in that interval such that when you find the average value, that is actually equal to what happens when you plug c into f. So in other words, this is a y value that's equal to the average value. So somewhere in the graph, you can find, so the way we found that our answer was 52, somewhere in the graph, we'll be able to find 52. And I'm going to show it to you. Okay? Just like this. So here is, the red is y equals f of x, which equals 3x squared. Okay? And here is 2. There's f of 2. And here's 6. There's f of 6. Okay? And f of 2, right, that's 3x squared. So that's 3 times 4. It's about 12. And f of 6 is 3x squared. So it's 3 times 36. So that's 108. So it's up here over 100. And now I claim there's a c somewhere in here. This is the interval from 2 to 6. Down here, there's a value of c that's equal to 52. So let's see. There is 40. There is 60. And you notice this blue line? I helped myself out a little bit. It's a little bit bigger than 4. This point is the number c, comma 52. So f of whatever that c value is the 52. Now, does that look like the middle point? Which is an interesting question. Now keep in mind, what was the average? The average was, we take the integral, which means we take the area under the curve. And then we divide it by how wide this is. So we're taking this whole area, and and dividing by how wide this is. And by that, I claim that this point is it is a center. Now, you might notice, you might say, well, it's a little bit low on the curve. And it's like, yeah, but there's a lot of weight down here. And this one gets really narrow up here. It's not a lot of weight. So it kind of makes sense that the weighted average would be a little low. That's just for me. It may be that you'd look at it and see something else. Okay, I got one more thing I want to try. So let's come back over here. The average, which is f of c. So there's a value of c that equals this. But that also means that if we multiply both sides by b minus a, f of c times b minus a is what we get for the integral. What in the heck does that mean? Okay, so let me show you. This I'm going to draw a picture of. Right? This is the area under the curve. This is where we started this chapter. Chapter 6 started here. Oh, let me see if I can make this slightly smaller without messing up the whole thing. There we go. Oh, you see I have extra pens waiting and paper and everything. You see all my secrets here. Okay, so the integral from 2 to 6 is the area under this curve. So that's this. Okay? So that's what this part is. This is this part right here. Okay. Right? Now, what is this? This is f of c times 6 minus 2. That I'm going to do in dark purple. Okay. That is this width times this height. So, in other words, I can take this really interesting shape, almost a triangle, not quite because it's kind of round and it doesn't have its whole pointy bit over there, and I can convert it into a rectangle. This is f of c, right? That's that value of c that equals 52. I drew it in for myself. And this is b minus a, which is 6 minus 2. So I can make any definite integral that gives me the area under a curve. I can squish it down into a rectangle over the same interval. The other way to look at it is there is a way to cut it off here, take this bit and bend it over and kind of squish it in so we could make it into a box if we wanted to. So that's what this theorem means. Now, in your actual homework, there's some really interesting applications. So I'm going to let you go on that. And you guys get to go discover that on your own, which sounds very exciting to SpongeBob. Make sure, if you get stuck, reach out, ask for help, ask each other, ask the tutors, ask me. I would love to help you with it. But hopefully this is kind of a nice palate cleanser after some really thick work, and not just thick work, but the rest of the chapter has been really thick. So the good news is this is a little bit lighter, a nice little dessert. So hopefully it goes well. Know that I'm really proud of you, and we made it through chapter 6. Yay! And we're not going to worry about how many other chapters there still are. But we made it through chapter 6. So that was amazing. You guys are amazing. As Ms. Beadle, my kid's first grade teacher, would say, kiss your brain. And remember that you're awesome. And go out and do something amazing, or just go take a nap. Get a good snack or a good rest or a good dance or some good art, or oh, heck, go do some more math if you're just like all on fire, like, yes, let's do math. And I will see you in the next video. You guys are awesome. Math on. Woohoo. May the force be with you. Okay, it's the last time I'll say that.